So you finished up your third law notes, you've gone through the practice, and now we just want to do a quick check-in. So the first one we practiced together was kicking the ball. And when we think about all these scenarios, no matter what it is, we're always focused on doing two things. One is figuring out what two objects are interacting and in contact to create these action-reaction forces, and two, what is the best force term? So is it that push or is it that pull? Okay, so with kicking the ball, we said it was like the foot pushes ball or ball, and then the reaction was ball pushes foot, right? And the key here was that these are not reaction in terms of like what happens next, right? Remember, these are happening at the exact same time, and they're happening to two different objects. So here we have one force acting on the ball and one force acting on the foot. So there was lots of different options for you to fill in here, and lots of the scenarios had multiple action-reaction forces happening in them. So really there's lots of different ways that you could have completed this sheet. But if we're thinking about some of the scenarios, we know there was a rubber band, right? So that one you could have said something like hand pulls rubber band, and then we'd have rubber band pulls hand, and so on. There was one where my daughter was simply sitting down on the picnic table, so body pushes table, table pushes body. We just were walking around, so there was lots of different scenarios. And I kind of gave you a variety so you could pick one that worked for you. So here you had the opportunity then to come up with your own scenario. So you either wrote it out or drew it, whichever was better. Basically, you're giving a little play-by-play of essentially one of those short little videos. It's got to have enough information so I know exactly what's happening. So make sure you have some detail here. And it's cool when people draw the pictures. Sometimes they'll like highlight a certain spot saying this is where the two objects are interacting. And then same thing here for your action reaction. Make sure it's what are the two objects, and also the best force word. And so those should just be opposites of each other. Part 4, this is where we really want to focus. We want to just circle the best choice here to complete the statements. So we've got two objects in every scenario interacting. We want to know what are their forces, and then also what's the resulting acceleration. So if we think about what the third law says, it says for every action and reaction, or for every action rather, there is an equal and opposite reaction force. Okay, so like for our guy with the soccer ball in the beginning, he was heading the soccer ball, right? In one instant, there was a force from his head to the soccer ball, and another instant, there was a force soccer ball to the head. They're equal in size and opposite in direction every single time. So as we read through these scenarios, we want to keep that in mind. Equal and opposite. So we have a bullet loaded into a rifle when the trigger gets pulled. I am not very good at drawing, but I'm going to go for it. I know that's not really a rifle either, but you get it. So we've got the gun putting a force on the bullet, and the bullet at the same time, equal and opposite force. So when I'm thinking about the force experienced by the bullet compared to the rifle, when I'm looking at these arrows, I am reminded that the forces are equal and opposite. So up here, when I'm thinking about their forces, it should be equal. Even though they're different objects, different mass, different size, the forces acting on them, according to the third law, are the same. But the acceleration experienced by them is different, again, because of that mass. So now we're thinking here of the bullet being the less massive object. It should have a greater acceleration. Here we have the baseball. So the bat is hitting the ball, and the ball is hitting the bat. When I think about their forces, every single time, equal to each other, but the acceleration will be different because of their masses. So the ball, being again less massive, will have a greater acceleration. Okay, here I have two football players, so I have a massive linebacker, so linebacker, and smaller halfback, okay. What do I know about the forces when they're tackling each other? Every single time, equal and opposite. The acceleration then is going to be different because of their masses. So we want to know acceleration of the linebacker, this guy. He's the more massive one, so I would see less of an acceleration. And again, all of these are having a different acceleration because of their difference in mass. There we go. Last one, I'm playing pool. I've got the 10 ball and the 14 ball, assuming that they have equal mass. 10 ball, 14 ball, they collide. What do I know about the forces? Don't make me say it. Equal every single time. The acceleration of the 10 ball compared to the 14, if we know they're the same mass, then their acceleration should also be the same. So no matter what the situation, I should see equal to for forces every single time. Acceleration is dependent on that mass. Less mass means more acceleration. I would take a moment right now, fire up your learning targets, pour that information into your learning targets, and get that ready to roll for Wednesday. As always, reach out with any questions. Screenshots are always helpful when you're wondering about something, so I can see right where you're at and how to help you out. Bye.